Sure. So I'll introduce myself. I'm Dave Wagner. I'm a computer science professor here at Berkeley, and I am one of the folks who's been teaching Data 8 from time to time. I'll be co-teaching again this fall, and I absolutely love the class, and I find it one of the most inspiring things I've done in my career.
I'm Annie Adhikari. I teach probability statistics and data science. And like David, I'm one of the people who has been thinking about the data science education program here since, it's 5 years, David. It's a long time. And it has been just stunning to me to see, what we were imagining take shape and then grow so quickly with so much student interest and support. And so I hope that we can take a little time today to talk not only about Data 8, but about the entire flow and the, what we had thought of as sort of an arc rather than a single course. Which, Eric, how would you like to do this?
I think it would be great if you guys could just, give a little conversation about your journey. I don't know if you had a chance to see John De Niro's, but it was sort of like a 5-year retrospective, and it was sort of like a look back on what the journey's been for the last 5 years.
So I'm happy to have a go. David, who goes first?
You go first, Annie.
I'll go first. I did have a chance to watch John, and in watching him, I hope you've got a sense of the way we've thought about this, which is that data science is not a sequence of techniques. It's not a bag of tricks, but rather it's a way of thinking, and it's a way of thinking that applies to everyone. And so the early vision was that, unlike some other places, we didn't start with data science as something that was intended for graduate students or senior ECS and statistics students, people with a lot of technical competence. Rather, we wanted everyone to be able to reason sensibly based on data. And so Data 8 is our starting point. You take the student whose qualification for the class is that they're at university. And so they're bright, they're curious, and they're ready to go. And we show them a way of really what we're trying to do, I think, is to face uncertainty. You heard John over and over again say, making conclusions based on incomplete information. Most of the decisions we make in our life are like that. And so we wanted, to the extent that we can understand uncertainty, that we can face uncertainty, perhaps quantify uncertainty, it helps us make good decisions. And so that has been our purpose. And so the arc starts with Data 8. You take students who have, whether they want to go further or preparation, which are, and we introduce them to reason. So to the extent that then they decide whether they want to go further or not, it helps us make good decisions. And so that has been our purpose, which are sort of lower time commitment classes, but they are focused on one particular domain or on going deeper into the theory. They can then go further. They can do the probability and statistics theory at increasingly deeper levels. They can do multivariate analyses with a little more computational competence. There's a course called Data 100. They can go deeper into the probability. And then in the end, they can bring it all together and come back to how do you make a decision in a course called, Data, Inference, and Decisions, which is 102. Throughout, there's a human context component. We don't want people to go out and just compute without thinking about the effect that this is having on lives. or what biases we are bringing into our own analysis. So we have a course on human context and ethics, but we are also trying to make that aspect of thinking woven into all of the courses. And that is, I think, a big part of what we're going to be doing over the next couple of years, once we've sorted out how to reinvent the whole enterprise in the coronavirus days. So for, I come from a statistics background, and I should say that Berkeley is thought of as a research powerhouse, but many of you will know that Berkeley has also been really quite innovative when it comes to pedagogy. In 1970s, Friedman and his co-authors wrote a book that transformed the way statistics is taught. And in computer science also, we have a very strong focus on developing undergraduate students. And we were fortunate in that these two departments have always worked very closely together. We've got a lot of people who are in both departments. And so this collaboration has been, well, for me, one of, I would say, the most enriching, valuable experiences of my life at Berkeley. Working with people like David, who comes in from a different background, and the openness of the computer science faculty, I hope reflected by the openness of the statistics faculty, to hear each other and to create something together instead of what I call a bar-coded class, which is, these are the CS days and these are the stat days, but to really mesh continuously, not just the content, but our own ways of thinking. That has been extremely valuable. So I hope at your universities you have that or will be able to develop that. Eric, if I can have a couple of minutes, I'd like to say a couple of words about the approach to teaching what is normally called statistics. Is that okay?
Yes.
Oh, David,
go for
David,
it.
do you want to cut in for a bit? No?
Go for it.
So John has already given you an overview, so I don't want to repeat what he has said. I do want to point out a few things for those of you who have taught statistics before, which is that in well, at least what used to be a traditional statistics course, we start with a statistic. Very often, we sort of compress the data down to, and there's the classic mean median mode. We compress the data down to a few numbers, and we work with those few numbers. But because we had computational power and visualization, we spend weeks just looking at entire distributions. We just look at the shape of the curve. We look at how all of the values are distributed. And so we don't have to narrow ourselves down to, do we use the mean or the median? We don't have to define the SD. And that is how we study sampling variability. So we start out by simply reproducing the sample, whether it be by simulation or under a null hypothesis by random permutation or by the bootstrap. We just generate lots and lots of samples and see how the data come out and how a particular statistic comes out, how it varies. And then based on that, we make a decision, an inferential decision, right? Whether it's a conclusion about a test of hypotheses, excuse me, or an interval estimate for a number. And it's only after this that we formally define an average and a standard deviation. It's only after this that we start saying, okay, look, you've seen all these shapes, and you can see some of them are wide, some of them are narrow. You can see some of them are bell-shaped, and some of them aren't. Okay, so what's going on here? And that is when we introduce the, someone need to mute a mic? Yeah, thank you. And at that point, the student is actually quite confident with moving, with working with data, and we can have the discussion of why the SD rather than anything else. because students always ask. And we talk to them about being able to actually quantify the statement that most of the data are within a few SDs of the average. We talk to them about the relation of the SD and the Gaussian curve. We talk about the central limit theorem, and we talk about standardization. We talk about looking at things all on the same scale. And the minute we've talked about standardization, we move to correlation, which is, after all, a feature of variables in standard units. And so what we've tried to do is to keep, we haven't gotten rid of what is considered really core material. We have just come at it from a different perspective because of the different tool that we have. And we have kept throughout the philosophical, what shall I say, integrity. What's the question? Why does anyone care? What are reasonable assumptions that you could make? And now, fine, you've done this calculation, you've done this visualization. What decision can you now make? That, I mean, we've been doing for, well, centuries. We're just trying to do it in this new context. So I'll leave you with sort of my favorite quote. This came very early when we were teaching. So we have this online forum called Piazza, and students post questions. And you see, we tell students, you want to see how, in what other way the sample might have come out. You've got this one sample, you want to see how else it could come out. And so you draw another sample, you draw another sample, you randomize. You keep introducing more randomization. And a student posted, why is it that introducing more randomization helps us understand what is going on? And you can see the philosophy of that question, which is that you're making things more higgledy-piggledy. Why then does that tell you a story? And I was thrilled with that, first because the question arose. In all my years of teaching statistics, nobody had articulated it that way. Everybody wanted to know something about the formula for the SD, and when do you use the t-test and when do you use the z-test. But here is somebody who got right to the heart of it. And happily for us, we did not have to answer. A student answered. And the student said, if you take many random samples, there's a pattern in how they behave. And you can use those patterns to make conclusions. I have the exact quote somewhere, but isn't that a beautiful answer? Patterns in randomness. That is part of what we try to do. And I was just, as a statistician, just thrilled that very early on, an undergraduate with very little background was able to not only pick this up from the course, but articulate it. And so that's basically what we're trying to do. We are trying to get students to be able to do the detail, but in such a way that they're also able to step back from it and look at a bigger picture. All right, excuse me for having taken up so much of your time. I'll hand over to others.
Shall we shift to Q&A? Should we take some questions in the chat, Eric? Would that be a good way to do this?
Yeah, that'd be great. So there's two ways. Please type your questions into the chat, or if you'd like, you can raise your hand using the raise the hand button, and we can unmute you. I think there was a question at the very beginning in the chat. I think somebody asked, how can they teach this at a community college with far less resources?
don't have a lot of experience or knowledge about what are the constraints at the community college level. I think the good news is that we have a lot of materials that you could borrow from that might make your life easier if you wanted. So one of the things that we try to avoid is we're not trying to design a new class every semester. So probably what I would suggest would be to start with what we've got. Get in touch with our data science division, and they could share with you the course materials, the assignments, the lab worksheets, the coding labs that they do for practice. And I'd probably start with the materials we've got and let the students work through it. And so that would basically spare you from having to do the material design, at least for the first run through. A large part of where the learning happens in our class, I think, is in labs and in students working together with other students. So that's one where I think the community colleges maybe have an advantage over us because of the small size enables doing a really good job of meeting the students.
Matthew Brett has a question about assessment, like how frequently you're assessing people. My university doesn't like assessment and tries to reduce them to 2 per module, but Data 8 has a huge amount of assessment. Do you think this is important? What would be lost without these?
Hey, Matthew, spring 2020 was an experience of, really reducing tests, like examinations. But when you say assessment, are you talking about the homeworks and the labs? I mean, we think of those as sort of exercises, much of which is done jointly. So maybe if you could clarify a little, because graded material, well, I mean, any instructor can choose not to assign points. But people learn through, I mean, they're going to learn this material, especially the computational component, through doing. And so if it is possible to encourage students to do the work, the projects, and not have them treated like tests, would that satisfy your university?
They're workbooks, not tests.
I think one take that you could try would be, I think that the feedback is very helpful for the students. So for instance, in our labs, we give them coding labs and exercises where there's immediate feedback, and they're immediately told if their answer has an issue. And I think you could try to expand that, for instance, and you wouldn't have to give any part of the grade for that. So we give points for that. And I think the motivation, my motivation for doing that is students, I think, benefit from structure. And if we give them some points, they'll do it. And so it's kind of just a way to get them to do the practice and to recognize the effort that they're putting into the practice, because that's how they learn. I do think there's a bunch of opportunities there for the regular weekly practice to be not something that contributes to the grade, if that helps. I saw a question about background knowledge and computer-related knowledge. So we're not assuming that people, our target audience is that we want to serve all incoming freshmen. So how much computer background do the students have? We assume no coding background. In fact, that's a very explicit requirement for the course. Are they proficient? Look, this is kind of the modern day, is that a lot of our students are reasonably proficient, certainly compared to when I entered college, about doing things like I could go into a web browser and I can Google for something, but we're really not relying on very much computer knowledge. Everything's through the browser. We teach them our programming environment. So I don't think it's that dependent on students having computer proficiency. They need to be comfortable in a browser and comfortable typing into a window, and not a whole lot.
There was a question about CS students being bored at the start. And one of the things we've tried to do is not to see the world as CS students and other students. So, I mean, when I teach a statistics class, you know, if you start out in the beginning, if you start out without computation, in the beginning, you're talking about averages and histograms and so on, the student who has done a lot of mathematics is probably finding that delivery a bit slow. It's okay. What they're learning is how to reason about data. So regardless of the background of the student, many of our early questions have to do with 2 or 3 percentages, and that will cause enormous discussion on Piazza. So yes, some parts, the programming might feel a bit slow for somebody who already needs to program, but they are also simultaneously answering questions on data analysis. What we found is that by about halfway through the term, we've done the programming that we're going to do. There's a little bit introduced later when we do machine learning. At that point, the student is very confident with the moves that they've learned to make. And so there's a different arc for each student. So the ones who have done no programming in the beginning, they do feel, I think, a little bit like it's coming at them rather fast. But they also begin to see that it gets used over and over again cyclically. We have found students with CS background take things a little easy in the beginning and then get hit by a truck in the middle of the term because they haven't paid attention to the data analysis, and now it's all coming together. But everybody in the end finds their place. And there are courses for students to continue depending on their different backgrounds and interests. I don't know if we have answered your question to some extent.
Do you need help from the IT department for course infrastructure? That depends on how savvy you are. So initially, we did all of the infrastructure through our students, and some of our students were computer science students, so they were very capable. And then we've transitioned to having help from staff. And actually, those are not the traditional IT folks who probably are not going to be, you know, maybe the most comfortable with this. So I think you could do a lot on your own. We have tutorials on how to set up the cloud hosting infrastructure for setting up the Jupyter labs. If you wanted to, probably the most challenging thing is if you wanted to set up our automatic grading infrastructure, that's a little painful. And so we have our teaching assistants do that. And if you had teaching assistants with a strong like coding programming background, they could do that. If you didn't, then what I would suggest is you don't use our auto grader. You maybe use our assignments and you manually grade them. How long does it take for non-CS students to learn the coding and start the analysis? Well, we're teaching about the first 3 to 4 weeks. We're teaching them programming, how to use the Jupyter notebook, and then mixed in there are some statistical and data analysis concepts that we're sort of driving the programming with. Each of these programming things we're teaching them, it's to, you know, it enables them to do some data analysis tasks. So think of it as the first 3 to 4 weeks are getting up to speed on the coding, and then we can dive into using that for the rest of the course.
Someone is asking, any ideas how to facilitate small group learning communities when delivering online? I'd like to relate this to a question that comes shortly after that. Hey, Adele, how difficult is this class for students in the lower 10th percentile of the class? So let me give you some sense of the kinds of things we've tried. Regardless of whether we're online or in person, we have these groups for what we call tutoring, but basically extra support in small groups. So students sign up to meet with tutors and teaching assistants in groups of about 3 or 4. and they work together on the current content, and that is a way of helping the student who needs a little more support, and also a way of making community. So we're trying to recreate those communities online. Now, David maybe should speak about the fall. You've been thinking about this a lot.
I don't know what we're going to do about the new online world. The in-person interaction of being able to work in pairs is so huge, or in small groups, and our experience has been not that great with the online. So what we're gonna try this fall is we're gonna try two things. We have our worksheets for a discussion section. We're gonna try doing that in groups of maybe six students and one TA, and to ask everyone to turn their videos on, and hopefully we can get some interaction that'll be less kind of imposing and intimidating if we can make the group small enough. And the other thing is we're going to do our coding labs. We're going to have people encourage people to do pair programming, and so we're going to send them into breakout rooms with two students per breakout room working on the coding practice, with a TA who can drop in when they need help. So that's what we're going to try. It's going to be experiment. I don't know. No one's really found a really good model that we've confirmed will work well in the online for getting kind of discussion and lab. And so this is a trial and error. But I think it's a great question, because for me, I think this is a central part of Data 8. One of the things that really makes Data 8 for me is there's this culture of students helping each other. It's very welcoming. It's not intimidating. It's not competitive. It's very unlike computer science classes I've taught, where our computer science classes are often this weeder class, and it's like there's stress and there's grades, and you're out every person for themselves, and look to the left of you, look to the right of you. One of them's not going to make it into the major, and this kind of thing. And Data 8, we've managed to set up a culture where students are helping each other, and they walk into lab and they know that there's going to be people there to help them if they're lost, and they don't have to feel bad about not understanding. And so I think that's how we're going to replicate that in the online world. Is a identity crisis for us in the new online world.
So to answer the question about the students who have difficulty with the material, small group tutoring has been very well received. So now we make it available. Of course, the difficulty for us is to identify which is the student who needs it, because sometimes the student who is struggling is exactly the one who sort of backs off and doesn't do anything. But if you can identify those, then working with them in a little group gives them confidence. And we've had a pretty good success rate and a lot of positive response to that. So again, we're reinventing everything for the online world. But I tried it in my upper division course, probability, and it was very successful and received very good reviews. So hopefully, fingers crossed, we can keep doing it at all levels. I'd just like to pick up on what David said. The culture that we create in Data 8, all of the students start in the data science program in Data 8, and it is collaborative. It's collaborative not only among the students, which is absolutely wonderful, it's even collaborative with the staff. You see, we give them the entire data set. They don't just have 2 averages, 2 SDs, and a correlation. They have the entire data set, and they mess around, and they ask questions. Well, what about ta-ta-ta-ta-ta? And you can tell them on the first day, wow, great question, I have no idea. Let's find out. And they realize that you don't know everything. And that really the more data you have, the more you realize that you don't know everything, and it's working together. So that then they take to the next class. And so whether they're going deeper into probability, whether they're going to data 100, prob 140, all of these classes, they bring that. And so all of our classes are seeing the same thing that David is saying. How do we keep this culture going? Because it's hugely important. They make friends in office hours. They make friends in data science office hours. And for the students who are struggling, that is a very, very important component. They work with each other, and well, fingers crossed.
Maybe you should say a little bit more about the small group tutoring. So we have this optional tutoring that maybe a third of students sign up for. That's groups of 3 to 5. That's facilitated by a course staff. There's a worksheet, and they meet every week, and they go. It's kind of practice with the course materials they're seeing in lecture, and it's not mandatory. At the beginning of the semester, we tell them, it's up to you, And if you'd like a little help, this is a great place to get it. And I think that's particularly relevant to the ones who are at the bottom percentile of the course who really need help. And we reopen it up again after the first midterm, when sometimes students discover, ooh, this is harder than, you know, I didn't realize I was going to be struggling so much. So that's, I would suggest looking into something like that. We also have experimented with individually reaching out to students who it seemed like were struggling on the first midterm, and hey, how can we help? And here's some resources you might want to consider, the small group tutoring. Here are some other things we can suggest to you. And I think that's effective as well when there's like a personal outreach.
There's a question of, is the material available in R as well, or is it only in Python? No, we've done the course in Python, and we'll keep it that way. One of the things that we try to tell students is, you know, you learn one of these systems, and then you can learn another. And so if you look at the courses, a couple of courses that are developed for the data science minor, one of which, Eric, do I have the number right? Data 131A. I think that's the right number. That assumes data 8, but then does the multivariate in R. So they spend a few weeks looking at the two languages and getting students used to R, and then they do they go deeper into data analysis using R. So take a look at that, and that has proved to be quite an interesting way for students to proceed. I will say that some students take data 8 along with some other class, but they are learning R. And doing the two together, unless you are quite unusual, can be confusing in the beginning. So we try to advise against that, to learn both at the same time, if it's their first experience of programming.
I saw a question about whether students present their work in some format. Great question. We used to. So one of the things we used to do is at the end of the semester, there was a semi-optional independent project where they could pick some question that they found interesting and find a data set relevant to them. And then we gave them some guidance on how to some questions to ask about their data set. But it was basically an independent analysis. So then they did that on their own, and then they prepared a presentation, and that we had a kind of a show and tell, the equivalent of a poster session, where the folks who did the independent project at the end of the semester showed it off to their fellow students, and we went around and we you know, heard their spiel and asked them a few questions about it, and graded their work. And I think they really liked that. There was some really creative stuff. You know, it was from things like studying urban decay. Someone else did some basketball statistics on their favorite team. Another person was looking at diamonds. There was someone who was looking at ecology stuff. It was really fascinating for me. And we stopped doing it largely because the size of the class grew, and we didn't have enough course staff to manage it. It didn't scale. So that wasn't a really very good reason. And if you have a smaller class, you might find that a really fun thing to do. But for the most part, they're not doing a lot of presentation to others. And I think that's because of the constraints of the class size. So the way that the presentation is coming in is when they're working in pairs. And that's not exactly presentation. That's the closest we got right now. Maybe that's an area where if you teach a course like this, you could make some improvements over what we're currently doing.
More of an institutional question. How long did it take for other departments and programs to require data 8, perhaps replacing their traditional stats class? Not long, and that was a concerted effort made by our then Dean of the Data Science Division and the head of the Data Science Education Program to go and talk to other departments saying this thing is available. Now, I will say that word got around from the students very fast. Data 8 was talked about. So departments have not replaced their traditional statistics class. They have said you can use Data 8 as an alternative way of satisfying the requirement. You can still do the traditional statistics class. There's very few departments that have just flat out replaced it. There are some departments who have made Data 8 a graduation requirement for a major and somewhat to our surprise, that didn't used to have a statistics requirement before.
Let me give you a different perspective on that. Can I disagree with you on that, Ani?
Please, please, because I come
Ani
from the
says,
stat world.
Ani says not long, and for me, I would say several years. This is a several-year-long project. So I wasn't involved in the initial creation. That was primarily Ani and John De Niro were the two masterminds of that. And there was a deliberate decision made very early on was that Data 8 was not a required course. It was not being introduced as a required course. It was being introduced as an elective. So the very first iterations of Data 8 satisfied maybe no requirements or almost no requirements for students. So students who were taking it for fun because they thought it was relevant to them as a, in addition to all the other requirements. And it was created because we saw a great student demand. We saw a huge number of students who were signing up for stats classes. We saw a huge number of students who were signing up for our introductory computer science class for majors because they felt like they needed to have these skills, and these weren't the right classes for them. So it was kind of a little bit of a long plan here that we were going to create a course we thought was going to be awesome. The students would decide whether they thought it was awesome, and indeed they did. They came and they took it maybe 50 or then 100 and then a few hundred, and then the word got around and students poured into this class because they saw it as so relevant to their future career. And so basically that's how the course grew and was enormously, was not through requirements and not through campus pushing it and not through us going to departments and asking them to require it, but through student demand. And then when a huge number of students took the course, then there started to be a conversation where students would go to the departments and say, why can't I satisfy this, this stats requirement with this course? Why can't I use this? And departments would start to notice, oh, hey, there's some pretty good material here. So this was kind of the plan from the beginning, was we were not going to fight the political battle to try to change a requirement to make Data 8 required from the start because we didn't have a product. Instead, we were going to start by creating something awesome and show how awesome it was. And then it's much easier to have that conversation when, when it's not coming from us and claiming, well, trust us, it's going to be great. But when actually it was like the students, demonstrating that this was really relevant to them. So it's been a process. And I wouldn't assume that it'll happen overnight.
I will say that my experience from the stat side is quite different from David's, because the departments were looking at their stat requirement and trying to see what's this new thing. So departments knew from the students and also from the faculty who were teaching our early connector classes that something very interesting is happening in Data 8. And I had to speak a lot to faculty who would ask, what is this? And if a student does this, will they know the statistics that we need them to know? And so the communication that some of the administration of the Data Science Education Program, myself, had with the other departments was just the statistics. What is it that they know? What can they do compared to what they could do before? I guess fast is, it depends on the usual speed of an institution. Berkeley is glacial. So by that standard, the fact that the course was piloted in fall 2015 and by spring 2017 dozens of departments had made it had said that, okay, you can use data 8 to satisfy the requirement. It was, for me, lightning speed. Sorry. So that's my usual expectation, that it's going to take, I don't know, a decade, but it didn't happen that way. I will say that the campus faculty have been extraordinarily open. In fact, we had people writing to us saying, you know, we need to learn this. One faculty member in I think, a humanities department wrote to me saying, I need to know what my students know. How do I learn this?
I saw a question about cheating. How much do we worry about cheating? Cheating is a challenge. And it's especially frustrating when there are these websites where you can go download solutions from previous semesters. And the philosophy that I've converged on is that I could spend an enormous amount of energy on preventing cheating, and that would help with a very small number of students. Or I could spend that energy on making better content, and that would help all the students. So my take on cheating is I focus on exams as a primary anti-cheating method. And I focus primarily on making great content that's going to be useful for everyone. And I've kind of given up on the idea that I'm going to be able to prevent cheating on homeworks. So we don't write new questions every semester. What we found is it's very labor intensive to create new questions, new projects. Each one of ours has been tested over multiple semesters. And the first time we write a new project or a new homework, it's got a bunch of issues. Like there's, you know, it's just inevitable that there's a bunch of them. And then we have 1,000, you know, 1,500 students take it. And if you write a completely fresh one, then you've gotten just dozens, or if you make one mistake, you might get dozens or hundreds of students asking for help at office hours, asking questions on Piazza, on our question and answer site. So what we try to do is we try to really minimize the amount of new assignments so that we can refine them and hone them over a period of multiple semesters. And I think we got some that are awesome. And if I had to create a whole new set, first of all, I wouldn't have the resources for it to do a great job. And second of all, I don't have ideas. I don't have that many ideas. Like these are using up our ideas over, we've been collecting in our back pocket over a decade of great data sets and great questions and great problems and great, you know, examples. And so we don't write new assignments every semester. We reuse them. And we have a little bit of detection methods so that we can detect if someone's maybe copy pasting from a previous sample solution. But by and large, our anti-cheating are the exams.
Can I ask a question related to that?
Go for it.
Yeah. So actually, I mentioned the chat. I did go through the Instructor Access, and I got access to materials. I find that some of the solutions to homeworks labs, they seem to be behind a Berkeley account access. Is that something you plan to make available to instructors? Precisely for the reasons you mentioned, it would be beneficial to look at, to reap from the efforts you all have put in. So just.
I was answering in chat. Yeah. So if you try to go directly link to the GitHub repos, you're not going to be able to get access because that's limited to Berkeley students. So what you need to do is you need to fill out the instructor interest form, and you'll be contacted by a staff member. And then we've set up a separate repository that will be shared individually with you after you make an agreement to hold it confidential, and that will have those non-public materials. So one of the things we're trying to do is we're trying to avoid having solutions spread all across the internet. And so we have a specific procedure. So if you're trying to do this today and you're just clicking on GitHub links, well, you'll be able to see the assignments, but not the solutions. So that's why we have this extra process.
Yeah, I've gone through that. I've talked to Eric and a couple of folks on your team. So does that happen automatically, or I need to follow up? I was not sure what.
Probably need to follow up. We have a process for that, and this has been recent addition that we're working on. So.
Okay, thank you.
Somebody asks about ADA compliance and accessibility. That's a very important question. So the question is, I teach at a community college. We got Data 8 course conditionally through our curriculum process, but it's being held up because of concerns about ADA, that's Americans with Disabilities Act, accessibility. Do you have any suggestions as to how you navigated this concern? So I would ask that you talk, Eric, maybe you could put Rebecca in touch with Suzanne Harrison of the Digital Learning Services. If you look at our edX version of Data 8, that has gone through the entire compliance procedure. For students in Berkeley, we have a disabled services program that provides all of the access that they need. But the details you will get from Suzanne Harrison and from our disabled students program. If you write to me about specifically what details, captioning to be ADA compliant, you will find in the publicly available ADA compliant captioning, you will find in the edX, Data 8X materials. Python has its own, Jupyter Notebooks and Python has its own compliance processes, which we used also. So we have looked at this very carefully, and if you send us a more specific question, we should be able to point you to the right people to say what we did. I'm not saying that that's the answer for everyone, but we can describe our experience in more detail.
I saw a question about instruction time distribution on theory versus coding. Maybe I might be given a little bit of a wrong impression here. So the coding part, we give the start of the classes, we're teaching them coding. The first 3 to 4 weeks is, here's your basic coding skills. And then the rest of the course is not about coding. There might be occasional places where we say, oh, here's how you implement this. And we teach you a little bit more about that, but not really. And I'm not sure I would call the rest of the class theory either. The rest of the class is several different concepts. And then each one of those concepts is driven by a bunch of examples. So don't think of this as like your typical statistics class, like the statistics classes I took with a lot of formulas and so on. In fact, one of the design philosophies was to minimize the amount of mathematics or formulas needed, right? I think for some students, the math is great and they're used to it, but for many of them, it's intimidating and it's scary and it's you lose sight of what's the concept behind it. And so that's one of the things that's really cool about being able to use once students learn some basic programming skills, is that then we can explain the concept and we can use simulation instead of formulas. And so most of the concepts are able to be taught with very little formulas. And so when we talk about theory, it's not the usual kind of like mathematical statistical theory. Instead, it's more conceptual level, like I don't know, the bootstrap method, talking about resampling and how the distribution of a resample is similar to the distribution of the original. And then we can go do some examples and look at them together and see how the shape varies and see how the size of the sample affects how similar the histogram of the sample is to the histogram of the original distribution. And so after the first 4 weeks, it's all on these new concepts and applying them. If you don't use auto grading, well, what's the impact? The impact is then you need readers or graders or teaching assistants who are going to manually grade all those assignments. So if you had 20 students, you had 30 students, no problem. It would be like the kind of grading load you're already used to. We have 1,500 students, and there is no way we're doing that for 1,500 students.
Let me answer this. Sorry, I was muted. What motivates you to be so generous in sharing your materials and propagating your vision? Let me just say that data science is a collaborative enterprise. And we've tried to teach that to our students, and we're trying to also practice it among faculty. And we would like to set a new standard for collaboration across universities if possible. So we are making our materials available. We hope that you will take them and create your own things and make those available also for us to use. Right, so we would love to see a back and forth about ideas. And really, these are not our ideas so much as it's our way of expressing sort of very I don't want to use the word old, but very fundamental ideas in evidence. So we're happy to share. And I will say, for us as a public university, it matters a lot that the student doesn't have to pay. It matters a lot to me, and I think also to my fellow course developers, that the student just opens a browser. And if a student can't afford a laptop, there's a library lending program where they can borrow a Chromebook for the semester. Right? They just open a browser and it's all there. And we wanted that to be the case.
I saw a question about incorporating bite-sized pieces of data and Jupyter notebooks with a little coding into your stats class. I think that's a great idea. And this is another piece of the program that we haven't talked about, which is I'm helping teach Data 8, so that's what I know best. But actually, there's another movement that's happening in a number of courses where instructors are integrating small modules into their existing courses. Maybe it's one day, or maybe it's 2 days. Right now, a lot of that's happening actually through our undergrad students who've been through Data 8, who are passionate, who've seen how to use this. Then they work with an instructor, and the instructor has a vision. Here's what I'd like to teach. And then the student works out, okay, how can we create some exercises around that? How can I do some data analysis around that? Now, I think that's a little easier to do for upper division courses, where you can assume that students have already had some background in Jupyter notebooks and coding, and then that gives them a basic level of proficiency, and then you can go apply that to some, maybe it's a biology class, and you could do with some, biological data set. So it might take a little thought about how to do that for classes where you assume that students have no prior background, because you don't want to spend all your time on teaching them coding. But I think it's a great idea to give students some exposure in a way that might be, less an easier way to migrate into integrating some of this into your curriculum by doing maybe a week or something like that in an existing course, rather than having to create a whole new course. One thing you might look at is maybe giving them pre-built Jupyter notebooks with some tuning knobs that they could change. So for instance, you show them how to do some kind of visualization, and then they can adjust the visualization to answer some questions. That might be something that you could work out ways where you've done the coding for them, and then they can do the data analysis and figure out what questions to ask, or what version of the question to ask, and then draw some conclusions and some interpretation, and figure out how to write that in jargon-free language. I think those are some pieces of the data science analysis loop that might be very amenable, even if your students have no prior coding background.
There's a very fascinating question at the end about what do you think about students who like Data 8 helping either set up classes or working as assistants in classes at community colleges. Berkeley students working at community colleges is something we have not followed up on. That is a very interesting thought. Please shoot me an email, shoot Eric an email. Let's see what we can do. David, there's somebody's asking, what's the benefit of using Data 8 on Jupyter Hub versus downloading students downloading their own Jupyter notebooks? You'll give a more experienced answer. I will say that in advanced classes, which assume data 8, we are also still using the hub. We are not asking students to download.
Sorry, I was muted. There's a huge reason why you want to use a Jupyter Hub and not have students run their own Jupyter notebooks. And that's, you don't want to be tech support. And if you have students download and run their own Jupyter notebooks, first of all, it's fiddly to get it set up on your own machine. And I guarantee there's some students who are going to go awry. And then, you know, halfway through the semester, something's going to break and they're not going to be able to do their work. And you're going to have to be there answering all those questions. And, you know, one person's going to have a Mac, another person's going to have Windows. Everybody's going to have their own weird custom install. And, oh, it's a nightmare. That's not how you want to spend your time. So I definitely recommend setting up the Jupyter Hub. We have a tutorial on the data science site called 0 to Data 8 that walks you through steps of how to set up a Jupyter Hub. If you have some technical skills, some coding skills, I think it's very worthwhile if you can. If you can't, you could follow that approach, but that was why we did it.
So I'm happy to take any last questions. If not, I do want to say a huge thank you to all of you guys for taking the time to do this. You know, it just gives us a very a massive motivation to make sure that we keep improving things. This is my summer to organize a group of data 8 developers to go over the textbook, make it better, and so we'd love your ideas if you have them.
And with that, we've come to the end of this session. So thank you, everyone. You're welcome to contact me, and I will do my best to try to help if you have further questions. And I hope you find this workshop helpful. Good to see you all here.
Thank you all. Bye.
Bye.